Welcome to our video on section 3.6 of the Red Book, Problem Solving Using Charts. So this first example has a chart already given to us, and what we're going to do is read the information and just organize it. And we're not actually going to solve anything on this particular example, but just kind of introduce the idea of organizing information so that we can then put it into an equation to solve. Okay, so in game 2, Jesse scored twice as many points as Ramon. In game 2, Jesse scored 6 fewer points than he did in game 1. In game 2, Ramon scored 8 more than he did in game 1. I don't know about you, but my head starts to spin when I read all of this. So by taking our two people, Jesse and Ramon, and making them rows, and then knowing that we have two games, game 1 and game 2, we're better able to sift or sort through the information. So in the first sentence, we see that in game 2, Jesse scored twice as many points as Ramon. That indicates for me that if I make Ramon my x, then I can go ahead and make Jesse 2x. And that was in game 2. So I'm starting with that second column. Now in the second sentence, we have a relationship given between game 2 and game 1. So I'm going to highlight that in pink and we'll go through that. So here we have in game 2, Jesse scored 6 fewer points than he did in game 1. So if game 2 is 6 fewer, then game 1 is 6 more. So I'm going to go ahead and make this 2x plus 6. And then our final sentence, we're going to have something about Ramon that we can actually put in this last box. In game 2, Ramon scored 8 more than he did in game 1. So game 2 is 8 more, which means that game 1 is 8 less. Now by doing all that, we can then form a relationship. Now, they didn't give us enough information in this question to solve a problem. All we were doing here is organizing the information. So let's go ahead and look at number 2, where we're going to actually use some solving skills. So we have a banana and a peach, and we need to find the total number of calories in each. So what I've done is I've gone ahead and organized our chart. Notice that my two items, just like our two people before, were in the rows. My banana and my peach are my rows, and my calories, and in this case our comparison, are my columns. So first thing we're going to do is we're going to read part A, which says a banana contains 65 calories more than a peach. So again, I'm thinking X is peach, because I usually like to make my variable my smaller amount, so that if the banana is 65 more, I can add it. It certainly wouldn't be wrong to make X a banana, and then your peach would be X minus 65. Okay, so now what we have is it has a relationship here of 10 peaches have 50 fewer calories than 4 bananas. So that's where if we go ahead and make this relationship, we can think about then putting that second part, part B, into a relationship or an equation. So all I'm going to do is think about the fact that the relationship is comparing 10 peaches and 4 bananas. Well, we know that a peach is X calories. Therefore, 10 would be 10X. And we know that bananas are X plus 65. So 4 bananas would be 4 times the quantity of X plus 65. Now we can go ahead and use this relationship that says 10 peaches have 50 fewer calories than bananas. So, but 10 peaches are not equal to 4 bananas, they're 50 less. So to make them equal, I would have to add 50 to the peaches. So again, I'm going to just put this in words so you can see what I'm talking about. We're going to write this as peaches plus 50 calories is equal to 4 bananas. I should have written this as 10 equals 4 bananas. In other words, we have to figure out where that 50 calories up here goes. And because 10 peaches are 50 less than 4 bananas, to make them equal, we would have to add 50 to them. So that's going to give me an equation that looks like this. Again, sticking with the peaches on the left, I'm going to have 10x plus 50 is equal to 4 times the quantity of x plus 65. All right, so we took our organized information and we wrote an equation. Now what I'm going to do is just quickly solve that by using the distributive property to distribute the 4. And then, let's see, that's going to be 260. And I'm going to go ahead and just subtract the 4x here. And I'm going to continue this right over here. So I'm going to get 6x plus 50 is equal to 260. And then I'll subtract that 50. And that's going to give me 210. So I've got 6x is equal to 210. And now when I divide both sides by 6, I should get what my x is equal to. And that's going to be, when I put that in the calculator, that's 35. So we know now that a peach is 35 calories. And a banana let's see, we've got to do 35 plus 65. That's is 100 calories. That's going to come out nice and even. Okay, so that is an example of how we can use a chart to help us solve a problem. All right, whoops, I just moved that a little bit too much. Sorry about that. All right, so let's go ahead and go to number 3. And in number 3, I'm going to, again, I already have our rows and columns done. So we want to find the number of full 8-hour shifts that Cleo worked last month. He worked 3 times as many 8-hour shifts as 6-hour shifts, and he worked a total of 180 hours. So do you see how we have the number of shifts and the total hours? We're going to see this pattern a lot, where we have a number of something and then a total of something. So in this case, what I'm going to do is I'm going to go ahead and think about the fact that, oops, sorry about that. We have 8-hour shifts and 6-hour shifts. So in the first part, A, it says he worked 3 times as many 8-hour shifts as 6-hour shifts. So I'm going to make the 6-hour shifts the unknown, again, whatever variable you want to choose. And that allows me to then make 3 times that unknown my 8-hour shift. Now we know that an 8-hour shift is 8 times the number, and we could simplify that right away to 24x or not. And the 6-hour shift is going to be 6 times the number of shifts they work. And because he works a total of 180 hours, then we're going to do, you'll hear me kind of say this phrase a lot, we're going to do part plus part equals whole. So we're going to do 8-hour, let's see, let's phrase that a little differently. Let's go hours from 8-hour shift plus the hours from 6-hour shift equals total hours. Again, you don't need to write that out each time, but I want you to see where this is coming from. So 24x, or 8 times 3x, is going to be the hours that were earned from 8-hour shifts, and 6x are the hours earned from the 6-hour shifts, and all together we know he worked 180 hours. So we can see that we have part plus part equals whole. So altogether we have 30x is equal to 180. When we divide both sides by 30, we can just as a reminder that shouldn't be getting our calculator for that, because when those zeros are stacked, we can just cancel those out, and we know that 18 divided by 3 is 6. So it would be, we wanted to know in this question the number of 8-hour shifts. So that means that we're going to have to go back and we're going to have to plug it into the 3x here. So the answer would actually be 18. There were, let's see, Cleo, oops, it didn't change pens here, sorry about that. Cleo worked 18 8-hour shifts. Okay, so in the next question, number 4, it's a very similar setup. So I'm going to let you do that, thinking about the fact that we have 2 different types of cheeses, cheddar and Swiss, and then we want to think in terms of number versus total pounds. And so again, you'll see that the boxes each have a different weight. So I'm going to let you work on that and put your answer in the question box. All right, so everybody should have finished the last question, and notice what I did here on our very last example is I did not label the rows and the columns. And that's because I want y'all to take a minute and think about how you would label this. We want to find the number of 20 ride tickets sold. So we have 20 times as many 8 ride tickets as 20 ride tickets were sold. The total number of tickets represented 3,600 rides. So we still have something where we have a total, so we have a part plus part equals whole. But what we want to think about is how would we label those? So it looks to me like we have 20 ride tickets. So in other words, that's like a bundle. You can buy a grouping that would give you 20 rides. And then you can also buy a group of tickets that would give you 8 rides. So I'm going to, again, hopefully you're thinking, gee, how would I do that? But I want to think of my 2 categories as either I have 8 rides or I get 20 rides. Now remember how we talked about a lot of these have the pattern of a number and then a total? So I want to think of this as the number of bundles. So very similar to the 8-hour shifts and the 6-hour shifts, right? If I buy a package of 8 rides, then that's a bundle and it's one bundle. So now I can do the comparison. Here it says 20 times as many 8 ride tickets as 20 ride tickets were sold. So the lesser amount is the 20 ride tickets, and that's what I'm going to make my X. So bundles of 20 ride tickets. So I'm going to go ahead and put that here, and then we know that there were 20 times as many 8 ride tickets, so that's going to be 20x. Now then what the total is would be our actual number of rides, right? Or I'm going to put total rides. And every time we buy one of these 8 ride bundles, we get 8 times the 20x. So I'm just going to use parentheses there to show that multiplication. And every time we buy the 20 ride, it's going to be 20 times the x. So similar to the other part plus part equals whole, we're going to have 8 times the 20x, which represents the rides from the 8 ride bundles. 20x is the number of rides from the 20 ride bundles, and all together we have 3,600 rides. So we're going to have 160x and then plus 20x, and again that 0 doesn't look like a 0, so I'm going to fix that. And then when we combine our like terms, we have 180x equals 3,600. Divide both sides by 180. And that will give us our 20 ride tickets, which happens to also be 20. So our answer will be, there are 20 bundles of the 20 ride tickets. Confusing when we end up with the same number, but that's coincidental. Okay, so that concludes our introductory video on organizing our information into charts so that we can solve word problems.